Hello, hopefully you can hear and see me. You are here because you've joined the Weave online user group. My name is Tamo Nakahara, and I run the developer experience team here at Weaveworks. And during the seasons, twice per month on the second and fourth Tuesdays of each month, we have a variety of wonderful guest speakers on our series, and it's great to see returning people come to these talks. These are also recorded and put on YouTube later with blog posts with summaries and such. So we're very thankful to see a lot of you return and see our great guest speakers. Today, we have a great speaker from a company called Qordoba, and they are actually a use case of Weave Cloud. They also do a lot of really interesting things, but they are also a good user of Weave Cloud. So some of you have asked for hearing stories of other use cases, so we're glad to bring that to you. And then later, we'll have a short bit from Jeff Hoffer, who's one of our dev advocates, on continuous delivery best practices. So first, a word from our sponsor. If you haven't heard of Weaveworks, we are a startup company that was started by the makers of RabbitMQ. A lot of people know of RabbitMQ. So yes, our CEO, CTO, and some of our engineers come from that legacy. And we're also a Google venture startup. Our main product is Weave Cloud, which happily today Michelle will talk a little bit about. And I will show you this 1 second or a couple second teaser of some of the shiny things that we have to offer. This is one of our visualization capabilities on Weave Cloud. As you can see, you can click into processes, containers, pods, and hosts. And not only that, this is all in real time and in the cloud. It is our SaaS product. A great feature here is you can see we have our CLI capabilities, so you can go directly into a pod and make changes or deal with troubleshooting. We also offer other types of management capabilities, as Michelle will talk about, continuous delivery, as well as monitoring, which is based on the open source Prometheus monitoring software. So we kind of offer Prometheus as a service. So that's a little teaser. If you want to find out more about us, please go to weave.works. If you go to weave.works/help, you'll see other ways that you can meet us, the developer experience team. We're a series of dev advocates and community managers here to help you, and you'll find out how to join our Slack channel.
Well, thank you for the fantastic introduction, Tamo. This is a talk I'm especially excited to give because this is kind of the first time I get to really describe some of the things that our team has been working on over the past few months. So just a little bit of background on myself. I'm head of data science at Qordoba, and my background is in, both my degrees are in computer science, and I've done a little bit of work with natural language processing. And the reason that's so interesting to me is because when I was younger, I decided to learn another language, and NLP really gives me the opportunity to combine my interest in linguistics with my interest in computer science, and distributed systems was a natural follow-on to that, because you can do a lot more with NLP, the more machines that you have. And that's how I sort of got interested in Weaveworks. That's how I started working with Kubernetes and containers in order to enable better NLP. And something that I've really come to appreciate is emoji, so you'll see a lot of it in these slides. My favorite subset is emoji one, so hope you enjoy. Just really quickly, some of the things that we do at Qordoba, we'll talk a little bit about that. I wish I were building a universal translator. Unfortunately, that's not the case, but I am working on some other really cool things. And just to give you an overview of what I'll be talking about, Qordoba is really focused on the field of internationalization. So we'll talk about what I mean when I say that and why it's so difficult and what we can do to make it easier. I'll give you some examples of what it looks like when it goes wrong. That way you can understand sort of why it makes sense to focus on it. And we'll talk about some of the things that I've been working on in the NLP space for helping to solve this problem. I really focus on a lot of the machine learning at Qordoba. And so I'll talk about some of the solutions that we've come up with, and then we'll get into the meat of how we deploy all of that, what type of infrastructure we're using, and what our continuous delivery process looks like. And because I always get this question when I say continuous delivery, what that really encompasses continuous integration and deployment. And I use that as a term because it's really a process of continuously continuously delivering an entire application without having to sort of break it up into all these comparts and all these component parts and do things manually. It's really about automating the entire process. So just to get started, to give you some background on what Qordoba is, it's a startup based here in San Francisco, not too far from the Weaveworks office. And our mission is really to enable products to be released in every language by default. Machine learning, the advances in machine learning have really made this feasible to have a scalable process. There's really no reason to keep products in one language. So our goal is really to provide accessibility to everyone around the world, regardless of what their native language is. And I couldn't mention Qordoba without talking about the amazing team. The slide is a little bit out of date, but we have a fantastic group with a lot of diversity. And one of my favorite things is having a female CEO and having such strong female leadership. Everyone circled here is director level and above. We have a really strong leadership group with a lot of support from the rest of our team. So I'll start off with an example. And this is an example of, this is a picture of my apartment. And there's a couple of reasons why I might want to put it up on Airbnb. Number one, I mentioned I live in San Francisco. It's the mission. Rent is outrageous. And so it makes sense that I might want to solve the financial problem. But what's also really important to me is that I can maintain my language skills. So I mentioned that I learned another language as a teenager. And it's been a few decades since then, and I really like to keep up those skills so that they weren't for nothing. And so I'm really motivated by having people from Germany come to visit me. That's this language that I really love. I want to know what's going on, current events. And I'm really motivated to have Germans come stay with me, not necessarily English speakers. But the problem is that, behind the scenes, Airbnb's website has a translation for my description of my killer apartment. And diese Wohnung befindet sich an einem mörderischen Standort. That's a literal translation. Mörderisch means the same thing in German as it does in English. Doesn't sound very appealing. It essentially means murderous. So that's what we're looking to avoid because it really doesn't help me accomplish one of my primary goals. So how does something like that happen? Well, the localization process is really messy. Traditionally, it was handled by a lot of communication among humans. There are a lot of components involved, and there's a lot of sort of manual transmission of those components across departments. There are a lot of different people involved. There are screenshots and lots of different strings. And it's a real pain to manage all of that. And a result that I'm sure most of you are familiar with, if you remember the Got Milk campaign of the 90s, it was wildly successful in the US. And when they were ready to expand it, the Spanish version that they came up with was roughly akin to Are You Lactating?, which was a much less successful campaign in Spanish-speaking countries. So when it goes wrong, it can really go wrong. And we just think that there's another way. Technology has changed so much. And this is really kind of a legacy way of approaching the problem. So really core to the way we see managing content is to see it as kind of like, consider the Docker of content. It's extracting it out into its own separate layer. And when you separate that out from the application logic, you enable so many things. You can, in the same way that you can manage an application better if you have it in a Docker container, if you have your content separate, then you can do automatic translation, you can apply machine learning. You have so much more flexibility with it when it's separate. And the cool thing about this is that it's not just about different languages, it's also about different types of language. So if you are writing an obituary, you really don't want language in there that comes from social media. If you have legal texts, it needs to be very specific. And so it's really just containers all the way down. You want different types of language inside different languages, inside our platform, which is used by your platform, which is running on Kubernetes and Docker. Anyway, containers all the way down. So that's kind of core to how we're solving this problem. So quickly, I'll go through some of the problems that it does solve. Traditionally, content is really disorganized, and that's why we put it into a separate layer. And when it's that disorganized, you see the same strings appearing over and over again, and linguists seeing the same thing and kind of having to copy and paste a lot and just do a lot of extra work. And so we have something called a translation memory, and that's where we utilize a lot of machine learning to take away some of the repetitive tasks. And when something goes wrong, that Got Milk poster, it wasn't just on the poster, it was in commercials, it was on flyers, it was everywhere. And with our system, we really want you to only correct it once and have that reflected everywhere. So our system integrates with all of your platforms, just to make it so that you don't have to go touching everything manually. And the same concept when you have a new phrase that you want to add, you just add it in one place, and you don't have to redeploy your app. Things are in real time, and it just takes away a lot of the repetitive nature. The other thing, I mentioned screenshots. This is one of my favorite features. There's a lot of plugins, and so if you're a designer, you have your Photoshop image up in front of you, and you can translate things with a picture behind it so you know exactly what the context is, or you have a website up in front of you and you're changing things on the screen instead of just seeing a spreadsheet of text without any idea of where it will ultimately appear. And then also, this is definitely my favorite feature. This is the GitHub integration. Because as an engineer, I don't necessarily want to have all these phone calls. If I just see it as a PR, I can merge it whenever I'm ready, and it just makes things a lot easier. So communication between teams, it's meant to sort of streamline that and use human resources where they're most needed. So this is another quick example of, these are 3 areas if you're not familiar with San Francisco. There's Mission Dolores, which is my neighborhood. It's traditionally Spanish. There's Chinatown and Japantown. And if you are selling something and, without even having to go to a different country, just within a single American city, if you want to sell things, you can have very different approaches. You don't necessarily want that exact image in all 3 of those places. But what you might want is something a bit more unique to those locations that might have a much higher impact. And these are just some examples. It doesn't even have to be text. It doesn't have to be language. But images and music and colors and photos, all of that. The goal is really to automate everything and to help manage that. So that's the problem that we're trying to solve. That's your context. And like I said, my focus has been on a lot of the NLP components. And one of those big ones is affect detection. It's cool if you don't know what it means. It's kind of a fancy term for emotion detection. And what we're looking to do is understand the emotion that's associated with a piece of text. And that helps because we're trying to organize the translation process and automate as much of it as possible. And so the more information we have about each of those components, the better we can coordinate which pieces should be automated and when we should flag things as being a bit off, when we should have humans look at those one more time rather than just automating them. So a few examples of this. This is a phrase that we send into our affect detector. It's a pretty, straightforward sentence. I had dinner with my wife. You might imagine what emotion could be associated with that. There are a lot of different ones depending on the person who's saying it. Our affect detector gave us this. Now this is, a result of the training data that we fed it, but we gave it a new sentence and we only changed one word. We didn't even change the gender of that word, but we got a very different emotion. And you can imagine why that might be important. Those 2 sentences are not interchangeable and they can't really replace each other in a lot of contexts. So having that emotional understanding of the difference between the 2 could save us from putting out content that we don't necessarily intend to put out. Another example is if I'm in the mission, I'm trying to sell this watermelon and I'm understaffed, I need some help. Maybe I'm sad because I'm overworked. If I translate that into Spanish, and my Spanish is not great, this is absolutely something that I would have said, that translation might evoke a very different emotion. And this particular one is roughly akin to get off your lazy butt and get a job. So this is where we would want to know automatically what the emotion is. That way we could take another look at that translation. And similarly, the phrases that we looked at before on my Airbnb listing, those also have very different emotions. So this is why we care about it. This is why I spent so much time working on it and why specifically it's important for localization. So when I joined the company, I set out to build this affect detector, and I came into a really well-organized system. It's a typical microservices architecture where there's a front end and a bunch of microservices, and then an orchestration layer in between that coordinates activity between all of those different services. And so what I was looking to build was just a separate microservice, just like all of the others, but that could do all these specific things. It had to sort of fit in by providing a REST interface that this orchestration layer could talk to. It needed to be able to scale up and down because we're a startup, so we started out with not very many customers, and we've really grown to having a lot of content, and we can't rewrite all of our stuff, so it's got to be scalable. And not just in terms of scaling out to different machines, but also it's got to support every language. We're not going to build those overnight, and so we need to be able to scale it out across all the different domains that we talked about, all the different containers. It's got to be useful, and part of the reason I joined Qordoba is because there's such a focus on open source, and so it was important that we were able to use open source components and also take parts of the things that we're building and open source those as well. So we ended up choosing Prediction.io as a framework for a lot of the machine learning components. And if you're not familiar with it, you might remember this scene from Apollo 13 where these rocket scientists get locked in a room and someone dumps this bag of parts onto the table and says, we need this one specific thing and this is all we have to do it with. It kind of felt like that trying to build this because there are just so many components. But what it does result in is a pretty scalable solution. So this is kind of the only NLP slide you're going to get. I don't want to go into too much detail here, but to give you some context if you're unfamiliar with what it means. This is really zooming out and oversimplifying, but essentially what NLP involves is taking something that's text-based and turning it into numbers, because once we have it in numerical format, then we can run mathematical formulas on it. And that's how we're able to provide predictions. We essentially fit a formula to a data set and use that to determine, to identify patterns and to determine where it fits in context with all of the other data that it's seen. So the first step in that process is to take text and turn it into numbers, and that's called feature extraction. That's taking characteristics that show up in the natural language and turning that into essentially a set of numbers. And that could be as simple as just a vector of doubles. It can be a lot more complex as well, but this is, just at its most basic level, you're taking text and turning it into some form of numerical representation. And then training is the part where you give it an answer key, and you essentially take all of this data, all of it with answers, all of these numbers, and send it to a function that takes all of it and fits a formula to it. And once you have that formula, then you can make a prediction. So you can send it a piece of text that'll get turned into numbers, and it will spit out a classification for you. The classification part of the answer key. And in order to figure out how good your models are, because the prediction doesn't do you much good if you don't know how accurate it is, that's the cross-validation phase. And that consists of over and over and over again running through the training process and evaluating it. So taking subsets of that answer key, running it through the predictor, and then determining how close that was to what it's supposed to be. And standard is tenfold cross-validation. So the training process itself is very resource intensive. Cross-validation is even more so. It's 10 times as resource intensive. And then once you get those results, that's when you would tweak some parameters. That's the hyperparameter tuning phase. You might change some of the input to your algorithm and see how that affects your accuracy. And so you might go through this process over and over again, many, many times until you have a prediction model that makes sense for your use case. So that's essentially what we're trying to deploy here. That's kind of what I wanted to talk about, because this looks very different from the rest of the platform, which is a set of microservices that provides a web interface that provides this sort of localization organization process that does a lot of storage and retrieval and sending of messages. This pattern this pattern is very unique, and it's unlike anything else in the platform. So we essentially have all of these different components that we want to deploy together as a cohesive platform. So this is the environment that we're operating in. This is a subset of the tools that we use. But the number one problem is that these pieces, so the rest of the platform, all of the different component parts, the billing, the history, all the automation, all of that looks very different from the NLP that we're trying to do with our affect detector. So how did we solve that? Well, what we did is we split everything up into containers, and we run it all on the same platform, and we just specify these are the resources that I need, so that one can't sort of overstep its bounds and take from the others, and that way there's always enough available for each piece to have what it needs. What exactly did that process look like? Before we brought affect detection in, everyone was happily operating in Mesos. Qordoba is a Scala shop, and so everything was just neatly packaged as a jar and deployed into this Mesos cluster. And then I joined, and along came the circus, and things didn't fit quite as neatly into these little tiny standardized jars. So what I did instead, since I couldn't deploy onto this platform, this is when I started looking at just building things in Docker containers and just trying to deploy my microservice separately from the rest of everything else. And what that looks like, I built a single Docker container that could perform all of those steps. So even within just building a predictive model, all of those steps have very different resource footprints, but it's important that they use the same code base. So if you're doing everything in serial on a single image, you have your data load step where you take in all of your training data. You use that to build objects, and then you send it to your training function. And once you finish training, you store your model, and then you can serve up predictions. So that's essentially the whole workflow if I were to do it all in serial in one container. But the problem is that prediction step is essentially just a REST service that sits there listening all the time and essentially just has to like plug in some numbers and look at an outcome. So it's much more lightweight. It doesn't need all the resources that the training stage does. And the other thing is that data load process, that happens just a few times. We don't get new training data all the time, but we are retraining over and over again. And so it doesn't make sense to have them all running with the same resources in the same serial manner. And what we did instead is we took out all those pieces, we separated them out, and we just gave them different entry points. So it's all still in the same image. It's all still using the exact same code base. It's still building the exact same objects. But what we can do with different entry points for each of those processes, for the data load, the training, and the prediction, is we can instantiate different containers from that same object. So conceptually, it looks more like this, where you have a data load job, you may have a few training jobs, and then your predictors that are sitting there listening all the time. And those can be running independently of one another, but they can all sort of run on the same cluster and talk to the same data storage layers because they're abstracted out. And you can kill things and stand things up independently of everything else. And that's what brought us to Kubernetes, because it was so simple to take this process that has traditionally required completely separate approaches for each one of those pieces and a lot of sort of custom tuning and deployment. We can essentially just wrap a couple of YAMLs around that one image and deploy everything in a really standard way, and essentially just ask for the resources that we need for each different piece. So what started out as just a single microservice in this one cluster ended up being a place where we could put the rest of the platform in. And so this is really where we saw so much strength, is being able to put everything all together in one, having everything have simpler communications and being able to talk to each other within the same cluster. This really changed a lot for us. So speaking of communication, that brings me to another thing that we really, really love about running on Kubernetes, and that's we ran into when we were managing all of the nodes on our own separately, and like maintaining our own Mesos cluster and having to deal with a lot of hard-coded IP addresses. Those change like the wind, and what we really love is that now we just refer to microservices directly. And the other cool thing is that there's no more port mapping. We don't have to keep track of which services are running on which ports and which node. Kubernetes handles all of that for us. And we can really just say, I want to talk to the affect detection service, or I want to talk to the billing service. And they're all standardized ports, and it's standardized basically across the platform. Any REST service is always on port 80, and everything just, it's much easier to develop against, because you know that any component throughout the platform that you need to talk to has this very easy way of referencing it. We also really like, I mentioned that we were maintaining our own Mesos cluster. So we use Google's managed Kubernetes. So we're not even having to maintain a Kubernetes cluster. It is magical. If we want to increase capacity or decrease it, we literally click that little pencil and then add a 0 to our cluster size. And all of a sudden we have all of this capacity. So it just makes it a lot easier to adapt to our changing needs, and also to scale down whenever we need to, and not have to worry about the headache of maintaining this infrastructure. We basically just define YAMLs. And this is where Weave comes into the picture. So we were really happy with Kubernetes, but we were still having to maintain those YAMLs and like keep track of them. And we have all of these different clusters. Like the cool thing about managed Kubernetes is that you can spin up clusters as you need them. But we had quite a few of those, dev and test and prod, and like prod on deck, and all of these different things that we wanted to keep separately, and they had different configurations. They couldn't all be talking to the same backend. We had to keep them separate. And so the release process, making changes and managing where that was going to go and when, was really starting to be onerous. So what Weave does for us, we make our changes, we'll create a feature branch, and we'll merge that into our develop branch or our master branch. And that's kind of it, because Weave takes over from there, and it notices that change, it saves that change, it deploys it to the cluster, and then these magical Kubernetes objects called deployments handle all of the rollout process for us. And it's really hands-off, and we absolutely love that in order to release something, all we have to do is merge a feature branch. That's been really transformative for us. So that's what, I believe it was Alexis who termed this GitOps. I don't know if it was originally his term, but Alexis has a couple of really good blog posts that describe this process. And I'll go over a little bit about what it looks like for us. It probably means something a little bit different to everyone, but this is what our process looks like. We start out by, like I said, merging a feature branch. We have a PR, it's been reviewed, and it goes into either a develop branch, master branch, whatever sort of thing we've defined as a standard branch. It goes in, and the next step is for Jenkins to recognize that. So as an engineer, all I've done all I've done manually is merge. And then what we do is we keep a Jenkins file with all of our repositories. We have one repository for each of those microservices. And the cool thing, so if you look at the top part of the diagram, that's all of the persistent configuration. The bottom is everything that's ephemeral. And that means that if we lose any of these ephemeral pieces, it's pretty trivial to stand it up and sort of pick up where we left off. And that happens because we use a Jenkins file and something called a multi-branch pipeline job. And that works by Jenkins. We basically just point Jenkins at our repo, and it looks at that Jenkins file, figures out what to do, and anytime it sees a code change, it'll do that. So Jenkins will pick up that change and build our Docker image. And then that goes straight into our image repository. So this could be Docker Hub, this could be Artifactory. For us, it's Google Container Registry. And once it's in there, this is where Weave is watching all the time. And we will see a new version of that image pop up. It knows exactly which image belongs to which service, and it can recognize that new version. And it knows that it needs to do something with it. So there's a way to automate your deployments. You can also turn that off. You don't necessarily have to, but we really like the automated release process. So Weave sees that, and what does it do with it? Well, the very first thing it does is it puts it into a persistent store, and it writes that change to GitHub. So it says, this version has been incremented. I'm going to go record that. And once it's done that, it applies it. So it does literally a kubectl apply new definition to the platform. And Kubernetes then sees, okay, there's a new version of an image. I need to kick off this rollout process where my old pods die, my new ones get started, and you can very sort of fine tune what that deployment process looks like. But essentially that deployment object does the rest. So Weave acts as sort of this in-between like event watching thing that keeps our GitHub repo in sync with actual state. So it's looking at which versions are running on the cluster itself versus which versions you have committed into your GitHub repo, and it's syncing those. So the other problem that we faced is that we had config files scattered everywhere. So let's go back and look at this single source of truth over here, this GitHub repo in the top right-hand corner. That's the place where we have all of these YAML files, and that sort of represents the current state of our cluster. Well, that's also where we're storing our configuration files, and that means that we have everything in one place. There aren't sort of IP addresses hiding in places that will come back to bite us, but everything goes into that one repo. And because it's all stored in that central location, it means that we can apply what is essentially a very trivial script and it's consistent across all of our services. We apply the exact same operations to every one of those services just in sort of like a loop. It makes things a lot more simple. And we store, so in that repo, it's not only the YAML definitions and configurations, but it's also, that's where we organize all of our different clusters. So that repo contains one branch for each cluster, because each one of those clusters is going to have something that's environment specific about it. And so you can still compare across branches. You can compare how the configuration for a specific branch has changed over time. You can still sort of, you can easily clone a branch. Like if you need another test cluster, you can easily clone that and then maybe change just where the backend is pointed to. But essentially it's one place to organize all of that persistent config information, and Weave accesses it, engineers can access it. It's sort of the one single source of truth. That's why we call it that. And so the other thing that I wanted to point out is that we started out by just having Weave access like the root of the repo, and it would just sort of deploy everything. And so one little trick that we found is to have two different folders in the root directory, one of them called deploy with all of our live changes. So everything, it's the current status of a cluster, and that's what we point Weave at. But then right next to that, we also have an abeyance folder with all of the stuff that's sort of on deck. So if we've taken a service out of a cluster for some reason, maybe we have some changes that we want to make, we'll temporarily move it to abeyance and commit that change. That way Weave doesn't sort of look at it and it can kind of leave it alone. We can deploy it manually for a while until we're ready to automate it. But essentially that repo becomes both a working area and a single source of truth, and we can maintain that all together per cluster by just having a different branch. And so whenever you have a configuration change that you want to modify, as an engineer, it doesn't just have to be automated by Weave. I can just go in and without even having to touch the cluster, all I do is I commit a change to that one repo and see what happens. A lot of times you want to try something to see if it fixes whatever problem you're facing. And because you have this in your commit history, you can see exactly what you tried, what worked, what didn't. And having that full like DevOps history can be really useful. But another problem that we ran into is that sometimes nodes will die. But because we always have that single source of truth living in a persistent state in GitHub, we can very easily reload from that repo. And sometimes not just a node will die, but an entire cluster will go down in flames. Sometimes it'll get in some sort of weird state that we don't really understand, or it'll just die and we'll lose communication with it. It's pretty trivial to rebuild because so much of it is command line based and it's automated. This is sort of the process that we go through when we're either rebuilding a cluster that's just gone down, or if we're creating a brand new one, like if we need another dev environment for whatever reason. So we'll take that existing branch and we'll clone it, or we'll just use the same one if it was a cluster that died. But we'll make whatever environment-specific changes we need to and commit that, and then run essentially what's a single script. It goes and it spins up these nodes. This is a gcloud command because, again, it's a managed cluster. But then we go into Weavecloud, we create an instance, and we give it a key, and that key gets deployed onto the cluster. Like, Weave gives us this whole script with a bunch of YAMLs. They have this really cool, I forget what it's called, really cool deployment tool. It's essentially a script that they generate for us that's exactly suited to our cluster. We give it our deploy key. We change we give like the Flux agent access to the deploy key. And then we run our script that generates all of our config maps and all of our objects and applies all of our YAMLs. And essentially, that's a single script. And because all of it is automated, it means that we can recover from a lost cluster in a much shorter amount of time than we ever have been able to before. So again, this is our diagram. It starts with an engineer merging a PR, and that's sort of the last manual piece. The rest of it is all automated combination of Weave sort of watching the container registry and being able to look at the current state and reconcile that with what we think our state is, what we have committed into our repository, and doing a lot of the heavy lifting for us and giving us a really beautiful UI to see all of that in. So that was kind of a whirlwind overview into how we're building a platform that scales. But that platform is really there in order to enable you to scale your application. And my challenge to you today is really not just to build an application that scales, but to build an application that scales in terms of content as well. So that's all I have for today. I'm ready for questions, but here are my contact details if anyone has something that they want to follow up with later. I'm more than happy. You can DM me on Twitter or send me an email. But I think we have a few minutes, Samuel, if you want to ask questions right now. Great.
Thank you so much. That was a really great presentation. I'll let people here think of some questions that they might have. In the meantime, I had a few to get things started. So I was interested, you said you started out as a Scala and Mesos shop. And then because of the affect detection, you had to rethink things. What was the timeline in terms of that transition? How major was it? And are you willing to share some areas where maybe you made and then dumped some decisions? And yeah, like how difficult was that?
Yeah, let's see. By the time I probably wanted to deploy it at some point, maybe early this year, I think. And yeah, I got a lot of like, you want how many nodes? Like, you want how much RAM? Our entire platform runs on less than that. There's no way you can have that, Michelle. So I just sort of backed away slowly and went away and kind of figured out the Kubernetes side just for my little piece. And that probably took a month or so. And then to get from there, so just having one service on Kubernetes to having everything on it and like live in production, I think we went live sometime this summer. So not a super long timeline, several months as well. And I think, you know, we were working with you guys because that was sort of the one, Weave was the one missing piece because we had these really complicated Jenkins jobs. It was a lot harder to shove that into a Jenkins file without the Weave component. And that was really what took us the longest, is those nitpicky deployment details. So I would say getting everything all standardized and tested. And by standardized, I also mean, I don't just mean like forklifting services into Kubernetes. I mean taking services that were really non-standard and like containerizing them, putting them into Docker containers, building Docker files around them, taking all of this config that was deeply embedded in all these different places and pointing out all these crazy things, like organizing that, storing it all in one place, and making that the same across microservices. I think JR, my coworker, he and I were like, whenever we were going through this process, I think we retired more technical debt just during that process than I think any startup ever has, because it was really broad strokes, just sort of taking like several years worth of development and sort of putting it into a more just sort of standardized, streamlined she went away. So I would say all told, maybe 6 months.
Okay.
Maybe a little bit more, but like, and pretty focused on that, not getting too distracted. Like I definitely didn't do as much machine learning during that time frame as I wanted to, but it was definitely worth it.
Yeah. And what would you say is the number, like how many people or how many teams are affected in terms of needing to ramp up and just learn Kubernetes, I guess, and learn new technologies?
Yeah, I mean, it was engineering and data science. We're not huge. We have, I think, around 20 people now, 20-ish people. And engineering is probably 12 to 15 of that. And yeah, there was a lot of really, really good collaboration. So we're really, really lucky that we don't have this sort of segmented data science and engineering. We're all very much one team. And I remember having these conversations with a lot of the backend engineers, and like specifically one of my favorite moments was talking to the front end engineers, which is code that I just never touched. I hadn't even looked at Qordoba's front end at all, and working with them to create, like, to containerize it and to make it sort of standard, because they were like, what? We don't really understand how this fits in. And being able to work with a team where like neither of us really spoke the other person's language, but we were able to change everything over so that we did speak the same language and so that we were all on the same page. And it was so successful. Like there was so little friction there. And I mean, the rest of the engineers were amazing. They picked things up really quickly. And like, it's a testament to how good the tools are, because it's really just generating these YAML definitions. Docker containers was like a little bit problematic because there's so many ways you can do it. But the Kubernetes piece, the YAMLs and the Weave piece, the deployment stuff, like that was pretty straightforward. So.
And then, of course, I have to ask, and you talk about engineers, and we're still learning. We ask around the word DevOps, like it meant something last year, 2 years ago, 5 years ago, what have you. Is that a meaningful term at Qordoba? Is that a job description? And if so, what does it mean for you guys? Yeah,
that's an interesting question. So I think in that, while I was working with those front-end engineers, their very first question on that conversation was, Michelle, are you our new DevOps person? Like, what? Like, what on earth? That was, I think, the most surprising thing ever. It's definitely not a title I've ever ascribed to myself. It is, I wouldn't say it's all that meaningful at Qordoba specifically, because we did used to have a DevOps person, and that person was very overwhelmed trying to manage an entire platform, like our own Mesos cluster, our own Kafka instantiation, like everything. He was basically maintaining it from scratch. And we've migrated from that model into all of engineering is DevOps. We don't have that specific role anymore. We do have, someone that has an overview of the platform, but like people who are writing the code are taking responsibility for that. And because all they have to do is merge a PR, it makes it's very empowering. It makes it feel like you're not just sort of throwing things over the fence and being like, well, I don't really know how many resources it's using, but just put it out there. It means that everyone's taking ownership for what they have, because everyone can look up their pod status. Everyone, like if you want to look at logging, you have to kind of do that yourself. It kind of takes away that need to pile everything onto one person or one team of people. It's definitely, the term has definitely transformed over the past year or so with us. And I think in a very good way. I think we don't have that one stressed person who's complaining all the time. And we don't have engineers ignoring things. They kind of, like, if they want to be successful, it's very much in their interest to pay attention to those things. And because it's so easy, it helps everyone.
Definitely. So we actually have a question. When you deploy changes, how much coordination do you need between teams? Are devs working independently? So I guess that kind of leads into what you're talking about a little bit.
Mm-hmm. Yeah, well, so as long as you're not making any changes to like the port or any of your routes, there really isn't that much. I mean, we have different environments. We don't just throw things into production. We have a dev environment where that's really our integration environment, where we'll take the changes from all the different services and we'll put them together. And then we usually deploy things like everything from that cluster over into a test environment to do like a final testing of everything together before we get it into production to make it live. But I would say there really doesn't need to be coordination unless it's it's touching any of those touch points between services. So like if I'm expecting information from a service, then I'll make sure that I test both of them. I mean, our engineering team is really very open. We do everything in Slack in like a single channel. And I think we do have some degree of it, but it's definitely less necessary now, I guess. And because everyone can see the PRs that are being merged, like if I know that I'm going to be touching one service and I want to make sure that it hasn't changed, I can always just go look in the commit history and see like has the configuration been changing lately. Like I said, that commit history can be really useful. Not necessarily having to talk to anyone.
Yeah. Yeah, and had to ask. So this architectural setup that you have today, have you guys discussed when you did that? So if suddenly overnight we got really successful and we had to scale, 10x or 100x or even more, are there things that you've already planned that you might have to do differently? You talked about that.
I think we've tried that. I don't remember what we arrived on, but we've done a lot of scaling up and down, especially when we were first setting things up, because we have so many different environments. And we really didn't run into any problems. Like it was literally as easy as just adding a 0. I think one thing that we took into consideration is which services we want running on every single node, and like certain sort of externally facing services that we want fast enough that there has to be X number of containers running, and there shouldn't ever be more than one on each node. We've looked at a little bit of that, but that again is just part of the deployment definition. It's something that you can, like as part of Kubernetes, define and specify. And so a lot of those problems were resolved by just looking up in the docs, like, okay, we want to be able to auto scale this particular thing. What's the field that I need to define in order to resolve that? But like, it's been pretty smooth and hasn't required a whole lot of adjusting. Like to go from a smaller cluster to a really bigger one, it seems to be straightforward. And like maybe there's something I'm missing, but so far it's been very straightforward.
Mm-hmm. Awesome. We have another question. How many resources do you have outside the Kubernetes cluster? For example, PubSub, Dataflow, TensorFlow, et cetera. And if so, how do you manage communication between the Kubernetes cluster and these resources?
Yeah, that's a great question. So I mentioned we're using Google Cloud. So we use a lot of their services. We used to manage all of our own like backend and Kafka cluster, all of that. We're slowly sort of moving to some of the managed services because it has been so easy for communication. We started using like one of the Google backends. What that means is having inside a pod, you would have like an extra container, like kind of like a sidecar that acts as a proxy to communicate with that backend. And with security, that's ended up being better because it simplifies the VPN management that we've had to do. If we can keep everything within that one like Google subnet, we've been able to solve a lot of security issues. With the PubSub question, Google has its own PubSub service, and we have started using that a little bit. And that is pretty simple. Like you store credentials in your cluster, and it's basically just a protocol that you call. We didn't really have to change much of our Scala code. I think we may had to add a library, but swapping that over from Kafka to Google PubSub was essentially just giving it a different link to connect to. So it really hasn't been a problem because we've generally stayed in the gcloud infrastructure. We do have plans to, so we're also looking at what that might look like on top of AWS, and what it would look like if we had to, instead of using the managed Kubernetes, if we got to a point where we did have to look at our own cluster, maintaining our own cluster. And that might move some of those things over into a different space. And primarily what we expect to deal with, if that does become the case, is more security implications than anything. I mean, I think we might take a performance hit of some sort, but we would be very purposeful about what things we moved over, and it would be at touch points that were very much that weren't necessarily time dependent. So like I might process some data and store it in an S3 bucket or a Google Cloud bucket somewhere, and then have another process that picks it up later. So I think you could be pretty strategic about it, but for now, managing everything within Google Cloud is working out really well for us.
Sounds like you guys are pretty happy with Google Cloud.
We are very happy with Google Cloud, yes.
Just a disclaimer, no pressure here at all. I'm just very interested because we ourselves, we're Kubernetes on AWS, and we just informally we've talked about like whether we might split things up, just make sure it's not all in one basket, but each has its pros and cons. We have our Sock Shop, which is a microservices demo app that anybody can use, and I think we're talking about moving that to Google Cloud because that's a little bit outside our thing, and we can't really be managing the Kubernetes clusters there too. So definitely pros and cons. But it sounds like it definitely works for your use case, the Google Cloud.
Yeah, I mean, I think the biggest pain point with using Google Cloud is that they can move too fast sometimes, and like I feel like that can be a good problem to have, especially as a smaller, more nimble dev team. Because we can respond to changes pretty quickly, and we are really interested in having the newest stuff because it solves problems for us that we've had to sort of hand code in the past. So like moving too quickly is a trade-off that we're willing to make because it also kind of forces us to improve our products, and it's kind of preferable to having the like rigid stability and guarantees because we can react pretty quickly to changes.
Yeah, definitely.
But now that we have everything standardized, it's a lot easier.
Yes, definitely. And I was at the most recent Google Cloud Next event, it's at least half a year ago, but machine learning was pretty much like one of the biggest topics around the event. Definitely putting their investments there. So cool. So we're actually getting very close to the end. The second part is always time permitting. We do have Jeff here. You can turn on your camera. I know he was sending me a little text. He's like, oh, she's talking about all this great stuff. I don't even know if I need to present. But Jeff, do you just want to pop in? And maybe did you have any additional or last comments? Just I don't want to go overtime. So what are your thoughts? Because you yourself, you're kind of out in the field, you work with different people.
Yeah.
Are there any just quick like tips and tricks or pitfalls you've seen out there?
I think the thing to take into account is that for each of your environments, you're going to have its own repo for managing the Kubernetes configuration for deploy to work with, and by having that, it's nice and easy. You can spin up entire environments by forking or copying the repo, but it is how you manage different clusters based on having different configuration keys and keeping them separated. But it also provides you the ability to only give access to people that, say to your production system. You don't necessarily need every engineer in there, especially if you have contractors. You don't necessarily want them to have access to see your production setup. So it provides a little separation of and security there.
Absolutely. Excellent. So with that, so thanks again for everybody for joining. Oops, all right. If this is your first time to this Weave user group, hopefully you've learned a lot about Weaveworks, and we're the team here, and we have a great user, Michelle. So if you haven't joined us yet on meetup.com, we have our Weave user group. You can see from there, we have this online group, but we also have some groups in different cities. So I think to do that, you go to meetup.com/pro/Weave. And then you can see we have London and the Bay Area and Berlin and other cities. And if you want help, if you want to talk to us, we have a lot of in-house expertise around Kubernetes and other areas. We are also contributors to a lot of open source projects in that community. So if you want to chat with us, this is how you can invite yourself to the Slack channel. So we'll also send out an email with the follow-up with this. So thanks everyone again for joining, and thank you, Michelle and Jeff. So we'll see you again.
Thanks for having me. This was
Thanks, everybody.
Okay.
Thanks, Michelle.